Okay, let's look now at two other limits that we have not yet studied. Um, the limit as x approaches infinity of square root of x squared minus 3 minus x. Why haven't we studied these two limits? Well, because here x is approaching not a finite number, but it's approaching infinity, okay? So basically, I want to know where are the output of this function going as x approaches infinity. We call that the end behavior. Behavior is with an E, and behavior of the function. This is actually something you have covered in pre-calculus. Not for this type of function. In pre-calculus, you've looked at the end behavior of a polynomial function, 2x plus 3 over x squared minus 1, 2x squared plus 1 over 5x squared minus x plus 2. In this third type of end behavior you've covered is this one, 3x squared plus 1 over x minus 5. Okay, you know that when the denominator here I'm sorry, that's a numerator. When the numerator has a degree smaller than the denominator, then the horizontal asymptote is y equals 0. When the numerator has the same degree as the denominator, the horizontal asymptote is the ratio of the leading coefficient. And when the numerator has a degree higher than the denominator, here the vertical asymptote, the asymptote will be not a horizontal line, it's going to be a slanted line. How do you find it? By doing the long division. If the degree is twice, is 2 higher than the, like if you got a 3 right here, then you're going to have a parabola, etc, etc, etc. Okay, so these end behavior were all covered in PC, and you can express all of that with a limit. Now, this one is different. We could look at the graph of the function, and actually you can, if you want, here, let's check out, maybe I can open my x, y, and let's see if we can, 10, 100, 1000, let's see if we have an idea in 10,000, let's see if we have an idea where the limit is going. So let me take my, right here, okay. Let's go to the Y menu and let's enter. So it is, where is it? Square root of, let me see, x squared minus 3. So square root of x squared minus 3. Let me get out of the roots. And then I think I have what? Sorry, I should have. Minus x. Minus x. Okay. Let's check out the table of value. We can start at 0, but it doesn't matter because I'm going to go towards infinity. I don't care what I move by. What I want to do right here is ask. Okay, I want to ask. I want the calculator to ask me. And let's see. At 10, what do I have? Negative 0.15. At 100, what do I have? Okay, it's about the same. At 1,000, what do I have? And at 10,000, what do I have? Okay, that means negative 2 times 10 to the power of negative 4. We can go on it maybe to read the result. Okay, negative 1.5 times 10 to the negative 4. Looks to me that maybe this is going to be the limit right here, negative 0.0015 possibly. This is visually okay. We could also, I'm looking at the limit at infinity, or maybe it's just 0 actually, the limit. We can also take a look at the graph. Okay, where can I, right here, large screen. And I want to see the graph. Where's my graph? Right here. And I would have to change the window because I'm interested in what's going on right here. It looks like it's approaching 0, but maybe it's not 0, maybe it's something else. I don't know. So let's go back to our limit. This limit actually is not very different than what we've done before. Let's see. It's not really called plugged in here, but let's kind of plug in and try to understand what we have. Okay, so let me rewrite it. So here I'm not gonna write, it's like 0.0015 some stuff. Okay, we can look at it numerically. We just looked at it graphically. It's somewhere here. I'm not sure if it's 0 or if it's something close to 0. I really want to know exactly what it is, so we need to study that analytically now. Okay, all right, so this one is gonna come later, so let me move it down. Up, down you go. Here we go. This is the limit. Sorry, here we go. I want to study then the limit as x approaches infinity of the square root of x squared minus 3x minus x. So as I said, let's try to plug in. Okay, it's not really plug in, but we'll understand what's going on here. If x approaches infinity, what can you say about the square about x squared minus 3? Okay, x is getting very large. X squared minus 3 is also gonna get very large, right? And so what can you say about the square root of x squared minus 3? It's going to get very large. Okay, actually let me just tell you something here. As x approaches infinity, we don't look at this right here, because when the number is very large, taking away 3 from the number is not very different than the number itself. So when x is infinity, we tend to think of x squared minus 3 as the same thing as x squared. And you can see right here, the square root of x squared is going to be, and I'm not going to put the absolute value here because I'm going towards plus infinity, x is positive, so it's going to be x. Okay, basically very close to x. So what do? You have a quantity that approaches infinity, and what do you do to it? You subtract infinity. So look, this piece right here is going towards plus infinity. X, well, x is right, I mean, it's telling you right here what it's doing. Okay, it's going towards plus infinity, and so you have infinity minus infinity. Now this, girls, is an indeterminate form. It's another one, we haven't seen it yet. It's an indeterminate form. You cannot conclude. If you subtract infinity from infinity, you may get anything. You may get infinity or you may get a number. Okay, so it's indeterminate, therefore you know what to do. We have to lift it up. We have to go further. So how do we lift up this indetermination? You know that too. It's the same. We've done that for expression involving square root like that. Just rationalize it. So I'm going to take the expression on the side right here, and I'm going to say x squared minus 3 minus x is equal to x squared minus 3 minus x times x square root of x squared minus 3 plus x over square root of x squared minus 3 plus x. Let's see. The top you have, oh, here it is again. That's gonna be the subject of the next video. Here you go. Alright, the top, what do we have at the top? A minus b, a plus b, so it is a squared minus b squared. Nothing happens at the denominator, of course. These x squared, they cancel each other out, and you're left with negative 3 over square root of x squared minus 3 plus x. Okay, now this is the expression. Let's go back to the limit then. So what do we have? We have the limit as x approaches infinity of square root of x squared minus 3 minus x is going to be the same thing as the limit as x approaches infinity of negative 3 over square root of x squared minus 3 plus x. Okay, let's see here if there's any change in what we had. So again, this piece right here approaches infinity plus infinity. Okay, this piece right here approaches infinity. What happened when you add two infinity together? They're the same infinity. Okay, well, you're gonna get infinity. Okay, if you add two extremely large numbers together, you're going to get a very, very large number. So now you're dividing -3 by a quantity that is very, very, very large. What is that? Well, that's going to tend towards 0, okay? If you divide a finite quantity by a quantity that is very large, either plus or minus infinity, it's gonna be 0, okay? To convince you of that, just look at the function, you know, y equals 1 over x to the n, and look at it as x gets very, very large, okay? So if you take 10, 100, 1, what is that? Here, 100,000, and on and on and on. The ratio is going to go towards 0, okay? So this is an important result. And we have determined then this limit as x approaches infinity. The fact that it is 0 basically means that the way this piece is going towards infinity, the way it's going towards infinity is exactly the same as the way this piece is going towards infinity, okay? Because when you do the difference, they cancel each other and it's 0. But that, we discovered that after, okay? If this piece was going towards infinity at a much, much, much faster pace, we wouldn't have 0. We may have infinity, for example, okay? So it's just expressing the strength with which both pieces are going towards infinity. We have 0, therefore it's about in the same way. Alright, I'll stop this video here and I'll do the next limit, which is kind of similar, but here you have an extra x, and we'll see what that does, okay? Alright, thank you.